There is another keyword which is or buzzword which is emerging nowadays in industrial applications. Cybersecurity solutions, 5G. Even though I have written as 5G, it may be some other communication interface, 5G, 4G, 6G, or even some wireless protocols which are used for data transmission. Then why industrial IoT is important? Nowadays, global players are investing huge amount in industrial IoT sensors, industrial IoT actuators, and industrial IoT operated devices. What is the what triggers them or what drives them to do such activities? So the main the outcomes of such industrial IoT or IoT based control system. The first one is predictive maintenance and asset management. I'm not spending much time on explaining all those keywords because the word itself is self-explanatory. Predictive maintenance, using sensors and AML or learning algorithm, we can predict the possible chances of breakdown or possible chances of errors. Smart factory automation. That is the ultimate aim of any IoT sensors or IoT operated devices. Supply chain and inventory management. Nowadays, industrial automation is not limited to a localized industry or a localized operating devices. In fact, it is we are now the industrial automation is managed in an overall manner. Overall manner means starting from the procurement, starting from the need aspect analysis, manufacturing, everything needs to be analyzed and needs to be automated. So supply chain and inventory management, that is another important thing. So using the analysis or sensor driven parameters, we can analyze and we can predict the need for a particular product at a particular location during a particular period. So accordingly, the manufacturing can be tuned in. Energy efficiency and sustainability. Then quality control, process optimization, mass customization. Mass customization is another keyword because nowadays the manufacturing is not for a long duration because the requirement of the customers changes. So as per the requirement, customer requirement changes, mass customization comes into picture, and accordingly for mass customization, the basic input needs to be collected through different IoT sensors. Enhanced workforce safety, global market expansion, energy efficiency, data driven decision making. So these are the different means I can say the different advantages or the different fruits which we can expect when an IoT or IoT based sensor system or IoT operated devices are implemented in an industrial environment. So I have few slides. I will quickly go through. First one is IoT in manufacturing. So the similar fashion, I have formulated the need for IoT operated devices in manufacturing, in logistics, in healthcare, and in agriculture. So IoT in manufacturing, the first and foremost thing is about predictive manufacturing or predictive maintenance. And second one is about smart factory automation, quality control, supply chain optimization, energy efficiency, and sustainability. So these are the how it is done. So in the previous slide, we have seen these are some of the aspects which we can expect when we adapt fully to IoT enabled factory automation. So ultimately the benefits, higher efficiency, lower cost, improved production quality, real-time decision making, sustainability. So these are the ultimate aims or the ultimate profit or ultimate goals which we can achieve by implementing IoT in manufacturing. Similarly, in energy management. So energy management, the IoT sensors plays a role in monitoring and optimization because the energy need is very dynamic. So there should be proper sensing mechanism to identify and to know the energy need in the near future. So accordingly, the optimization can be done. predictive maintenance of energy systems. There are lot of use cases are there. I'm not going into the details. Smart grid renewable energy integration. That is another topic because nowadays government is giving more importance or government is giving more thrust in implementing renewable energy sources in terrace or in open spaces. So there should be proper sensing mechanisms so that we can sync between the smart grids and the main grids, the smart grids and the renewable energy sources. Automated demand response, carbon footprint tracking, and sustainability compliance. So these are some of the use cases. And what is the benefit we are getting? Reduced energy costs, lower downtime, sustainability and compliance, optimized grid performance, scalability, and automation. So these are some of the advantages, or these are some of the use cases which we can expect. Coming to healthcare, real-time patient monitoring. That is the ultimate aim, real-time patient monitoring. So recently there was a case which I read. So one patient, he has some specific heart problem, but it was not repeating every time or on a frequent manner. So what the doctor does, he has implemented a small device which was connected with his mobile phone. In fact, the mobile phone is connected to the cloud and the data analytics will be done in the cloud and the inference will be transferred to the doctor's mobile. So what does is, if there is a deviation in his heartbeat or whenever it occurs, even though he is in deep sleeps, so those changes can be identified, monitored, analyzed, and the root cause for the disease can be identified. That is one case. Predictive maintenance of medical equipments, smart health, hospital management, drug vaccine cold chain. Because in during COVID period, we have seen the enormous need for drug and vaccine cold chain monitoring. Means the transportation, AI-powered diagnostic and decision support system. So all these are the different areas in which the IoT sensors or IoT-driven devices plays a major role in healthcare. And the advantages or the final fruit what we are getting: improved patient outcomes, reduced equipment downtime, operational efficiency, and enhanced drug safety, lower healthcare and cost. So these are some of the advantages or the final fruits what we can expect by implementing such technologies. So the final and the last one more is there on agriculture. The next one is on logistics. I will quickly go through the real-time fleet management and tracking, maintenance vehicles, warehouse inventory management. Because as per the study, more than 30 to 35% of the food products are getting damaged in the warehouse or during the transportation and inventory management. So if we have a sensor driven or if we have a proper analysis decision support driven logistics and transportation system is there, then we can very much reduce this usage. 30 to 35 tons means it is in terms of metric tons, it will be huge, which can even feed a large community, means a large group of people. So these are the areas where IoT sensors can play a major role. And the advantages: increased efficiency, lower maintenance, improved safety and compliance, enhanced sustainability, better customer experience. Then the final one is in agriculture. Why I placed agriculture in the last? Because the sensor development which C-DAC has attempted from my side. So that is on this agriculture side. So that's why I have put the agriculture, the need of IoT in agriculture as the last use case. Obviously, the IoT can implement precision farming or precision cultivation, smart greenhouses, livestock monitoring. So livestock monitoring, the face of livestock monitoring itself is changing, because previously it was based on some sensors means some sensors will be placed on the animals and those sensors will be giving the values. So it's a burden to the animal. We have to replace the battery and now with the face recognition and now with the proximity sensors, we can analyze and we can, because deep learning and AI algorithms will give more sophisticated outcomes based on these inputs. smart irrigation system, drone and AI-based system. And the key benefits is improved crop yield and quality, increased efficiency, improved sustainability, better animal health, and real-time data collection. So these are some of the advantages of using IoT. So far we have seen that different use cases, its advantages, etc. But there are some few challenges which the research community, because most of the participants are from research community or from colleges, students and professors. So these are the some challenges that needs to be addressed for a widespread acceptance of IoT based systems or IoT based sensors. Cybersecurity risk and data privacy, that is very important nowadays, because as the data increases, as the quantity and quality of data increases, then the need for cybersecurity and data privacy is very important, so that nobody from outside can intrude and inject packets, or nobody from outside can intrude and monitor the packets. So those kinds of things needs to be avoided, both at the transmission or communication level, at the edge compute level, and also at the final inference delivery level. Lack of standardization and interoperability, that is another thing, because as far as now it is concerned, even though there are some standards available, especially in the case of agricultural sensors, most of the sorry.
Can we kindly ask all the participants to mute themselves?
Yeah. Hi, thank you. High implementation and maintenance cost, lack of standardization and interoperability. Because as I said, interoperability is another important thing, because whenever something goes faulty, something goes wrong, then there should be an alternate mechanism to interface. So that is basically the need that highlights the basic needs of standardization and interoperability. And data overload and real-time processing challenges. As I said, as the number of data increases, the storage, the analysis part, the handling part, it is very difficult. So we have to find out some mechanism which is all these aspects. Reliability and downtime risk. Because once people get adapted to IoT or sensor-based automation and sensor-based system, we should make sure that the downtime is minimum or zero. Scalability and infrastructure limitations, workforce skill gap, and resistance to changes. So these things we can manage by imparting proper training or by giving proper courses, and we can handle all those things. But the rest of the things, few things I have mentioned in the first 4 or 5 points, that needs to be taken care by the research community very seriously, so that proper solutions needs to be implemented in the near future, as this area is developing or as this area is flourishing in a very, very fast rate. So coming to the sensor project overview table. So I have given an overview about what is IoT and its needs and different use cases and different application areas. So coming to the sensor project overview table. So these are some of the sensors attempted by C-DAC Trivandrum. One is in most of them are in agricultural field. One is agriculture NPK sensors. So NPK sensors, I have a detailed presentation, but it's in the range of TRL level 4 or 5. Then a rain sensor. We have developed a rain sensor for measuring the rain in urban areas especially. So and then from the conventional dip bucket system, here we have followed a load cell based rain gauge. we successfully demonstrated the prototype model also. So in this particular scenario, on a daily basis, the load cell will measure the weight of the water collected in the collection tank, and accordingly the rate of rain, or the how much rain was harvested in the last one day, last few hours, that can be calculated. Then another on IoT based system, it's not a sensor but IoT based system, that is the smartphone system. Then another on system on vision based sensor system for leaf analysis. So in the next couple of minutes we will be going through few of the slides. So about the sensor system. So NPK sensors, even though I have told it as NPK system, but eventually we have anticipated for both macro and important micronutrients. Means the macronutrients like NPK and macronutrients, important macronutrients like calcium, boron, and magnesium. Also soil pH. So these are the sensor systems which we anticipated to develop under the program. And agri sensor interface unit, means user interface unit, also was developed. So the particular soil sense system or soil nutrient analysis system consists of three subcomponents: electronic subsystem, mechanical subsystem, and chemical subsystem. Okay, so the right side image which indicates the mechanism. So here how we are doing is, because most of the times the farmers, how the farmers measure the soil, the nutrient content in soil, they collect the soil sample, they send it to some KVK or some soil testing stations, and after 2 or 3 weeks they will get the results. But here what we anticipated or what we developed is in situ soil moisture sensor or near real-time soil moisture sensor. The farmer has to collect the soil, he has to place the soil inside the sample collection portion. Immediately the mechanical system will make the soil sample into a slurry, and inside the slurry those electrodes will be placed, and according from the electrodes the different concentration of nutrients will be measured, and those values will be displayed in the mobile application or in the AgriSense electronic subsystem immediately within minutes. I can say within minutes, not in seconds, but within minutes. So this is a mechanism. So coming to the electronic subsystem, so here what we have done is we we have fabricated or we have designed an Atmel 89 on some 3x80 based module which accepts the input from different sensing elements, because the sensor element, as far as the sensor element consists of three electrodes: working electrode, counter electrode, and reference electrode. And in the next slide, I'll explain how the electrodes are working. So here, what we are doing is, from the electrodes, we will be getting millivolt or microvolt, or milliampere and microampere, ampere. So what we are using is, by using some amperometric circuit, we are amplifying this voltage, and those voltage or current will be amperometric and altimetric. These are the two mechanisms, two circuitry mechanisms, which we have used here to interface the system with the AgriSense module. AgriSense module is nothing but which is shown at the right side. So here the concentration of different parameters. Once I dip the electrodes in the slurry, the concentration of different parameters, especially N, P, K, calcium, boron, and magnesium, along with the pH value, will be displayed in the AgriSense module. And this is a mechanical subsystem. So the user has to collect the soil and has to place the soil inside the sample collection unit. Once the sample is collected, it automatically converts into slurry. We have a spiral mechanism, spiral, I can say that it is a spiral mechanical structure which mix the soil with the water, and the slurry will be collected in these different cubicles. Once the slurry get collected, the electrodes will be placed inside this each compartment. that we have linear and circular type soil sampling is there. So it's a portable kind of things, because every farmer doesn't need such a soil moisturizing system on an hour basis or on a day basis. So what we thought is we will make it as a portable, just like a pulling cart. So the electronic system and the mechanical subsystem, this auxiliary making, this control system for electrode placement, washing, cleaning, everything will be there. The only job is the farmer has to put the soil, connect the system to the power, switch it on. Ultimately, he will get the values in the AgriSense module in the display, which is placed at the front of this cart, or eventually he will also get the data in his mobile phone also. So this is the mechanism what we have used. It is nothing but selective membrane mechanism. So in selective membrane mechanism is nothing but you can consider a pen kind of architecture. You can consider a pen kind of architecture. Let's say this is a pen. So here at the end of the pen, there will be some selective membrane. So when I place this selective membrane in the soil slurry, depending on the concentration of the ions, because this selective membrane will be different. The membrane will be formed with a different means ion combination. This membrane will be formed. So whenever a nitrogen selective membrane needs to be made, so it is some different mechanism. So that particular ion only will penetrate this membrane, and when it penetrate and enter into contact with the working electrode, there will be a slight potential difference will occur. That potential difference we will measure, and accordingly, according to the potential difference, the corresponding concentration of ion or corresponding concentration of the element in the soil will be analyzed. So these are some of the novelty points of the particular experiment what we have done. And the electrodes can be integrated with a portable electrometer. They do not require any external reagent. External reagent is not required. The approach is minimum. Actually, we have filed some 2 patents and some 3-4 papers being published out of this particular design or this particular concept. And it's already filed, patent being filed. And these are some of the test results. First one is for nitrogen voltammetric method, and cyclic voltammetric method for phosphate ions. So you can see for multiple concentration, you can the linear. I have placed a linear curve. So the linearity can be seen from the images. Then for similarly for potassium, and these are some of the characteristics. The thing is, actually we have initiated this particular project with the help of DST funding, and the thing is now why I have said that it is in the TRL level 4 or 5 is now the productization and the field evaluation is pending. All the results which I have shown so far is on a laboratory condition basis, and but in actual soil only, but in laboratory condition base. Now the productization and the actual field evaluation to be done before completing the productization. So nitrate, phosphate, potassium, these are the different parameters which we measured, and its use means its stability in number of days and its usage. Most of the things we have measured in terms of ppm, sensitivity, linear range, all those things are measured. And how we have made, so the slurry. So here we have take 250 milligrams of soil and mixed it with the 250 ml of water to make the slurry. Allow the soil sample to dry, and we will get the slurry. We will take the slurry and we will place the soil in the electrodes. And here at the bottom, we have the chemical analysis result along with the this selective membrane technology result. Some deviation is there, but it is in par with the normal or conventional method, which took more than 2 or 3 weeks to complete. But in our case, it is within minutes. You will get the farmers will get the results. Okay, I have a small video. This is the electrode, and testing in blank solution. And what we are getting, it is shown, and 60 of nitrate sample. With the 60 of nitrate sample, how the result is going, how the values are getting stabilized. Now 30 of NaNO3. How the results are obtained. Yeah, 20 Then how, okay, then how the soil sample is made. This is how the soil sample is made, how the slurry is made. Okay, now the soil is ready with 20 or 30 and 60 These are the different packets which we made to do. Then after that, we will make it into slurry, and in this particular slurry, we will place the electrode. And the different experiments are done. This is a controlled sample. That's what. The samples we have taken fermented soil, and we have added 10 NaNO3, 30, 60, 90, like that, different concentration of NaNO3 added and made it to dry. And like that, we have made the different soil samples. And these soil samples for testing purpose, we again converted into slurry. And that particular slurry liquid, we are used to place the sensor electrode. So here the combined result. For different concentration. So this variation we are amplifying using altimetric or amperometric mechanism we are using. Then coming to IoT system, it is nothing related with the sensor, but it is IoT system. This is a smartphone system, which is a TRL 8 or 9, I can say. And already 2 TOTs been signed, and some other discussions are going on, and more than 15 or 20 installations we have completed. So this system, it is nothing but it accepts different sensor values from the soil, and depending on the sensor values, it controls field equipment. So in a nutshell, this is how the system works. Why I have said it's an IoT system, because it accepts different inputs and process, just like an edge device. It processes the input and controls the corresponding output. Similarly, the data will be transferred to the cloud from where it will be make available for the mobile app and as well as for the GUI. And these are some of the sensor technologies for agriculture, humidity, temperature. The main issue when we closely observe, why I have particularly mentioned agriculture industry, because the sensor cost is too high, and the reliability, sensitivity, and the sensor and the stability of the sensors in agriculture sector is very less. So it is high time that, because nowadays India is promoting smartphone systems or agriculture automation, precision farming, soilless cultivation. The basic element of all these systems is the sensor elements only. So it is high time that we have to give importance to these sensors, because the ultimate users are farmers. The ultimate users are farmers. So it is very difficult for the farmers to invest huge money. So we have to develop cost-effective solution. The NPK sensors which we developed, which is about 10,000 rupees per sensor. That is the costing which we anticipated when productized. Within that small value, the farmers could get the entire mechanism, so that a group of farmers can use the technology. Like that, we have to anticipate and we have to develop technologies for agriculture. Solar radiation, carbon dioxide, pH, electric conductivity, rain, soil fertility. Here I have developed the soil fertility sensor using chemical mechanism. There are optoelectric sensing mechanism is there, image processing for leaf image processing, and soil image processing. That is another important area. Actually, these are the areas where C-DAC is involved in. Smartphone system and NPK sensor system I have explained. The second one is something which is related with the digital twin, or I can say that it is something related with the data analytics part. the second and third and fourth, and the last one is leaf sense system. So I will briefly explain about the leaf sense system. So most of the diseases, most of the nutrient deficiencies, and most of the pest infestation can be identified. The first symptoms occurs in the leaf. The leaf color may change, leaf pattern may change, leaf orientation may change, leaf size may change. So once we could analyze these leaf parameters, most of the diseases, most of the nutrient deficiencies, because nitrogen deficiency is pale green, potassium deficiencies, leaf edges become gray. Similarly, for magnesium, the leaves become cup-shaped. And there are multiple symptoms for each nutrient deficiency, each pest infestation, or each means diseases. So in that similar manner, actually, C-DAC has developed such a system which measures which identifies some 3 diseases and 3 nutrient deficiencies in chili plants. We have successfully implemented the system also for a potential customer. We have done this using high-end GPU, because we have not used the cloud, because the system was implemented in a very remote area. So we have used a high-end edge device from NVIDIA, and the video data was fed to this particular system. It analyzes, and immediately the alert message along with image, possible causes and possible remedies will be displayed in the farmer's mobile. So that is about the leaf sense system. It can be because this particular leaf sense system is peculiar to a particular variety of plant and peculiar to diseases. So we need to expand it to more number of plants and more number of species, more species of crops, and more varieties of diseases and nutrients deficiencies, so that it will be very useful for the farmers. So I'm concluding with this feature vision, cognitive IoT, hyper-connected ecosystem, because 6G will give ultra low latency to the network, so which can even we can avoid the edge computer systems. Then bio-digital convergence integrated with the human biology, means brain-machine interfaces, smart prosthetics, etc. AI-powered assistive IoTs for elderly and disabled persons. So that is another thing. For elderly and assistive persons, it is very difficult to wear big devices with the needs to change the battery and all. Even if we can go ahead with some assistive health, means assistive helping without any intruding mechanism or wearing mechanism, then it will be very useful. Sustainable and resilient infrastructure, ethical and trustworthy autonomy, because when the number of use cases increases, or when the number of applicants or number of persons involved in this particular IoT based applications, in that particular scenario, we have to make sure that all these things are ethical and trustworthy, means it is transparent manner. All these things are getting, and in transparent manner, all these AI based systems are communicating each other. Interdisciplinary research and education is required. Global public-private partnership is very much important, because as far as it and IoT-enabled services are concerned, it is not an one-man show. It needs the people, or it needs the inputs from multiple persons or multiple agencies who are pioneers in their own area. So it's an important thing. Then innovation with impact. Impact is the foremost criteria. The industrial IoT is revolutionizing the industry by enabling automation, real-time data analytics, predictive maintenance, and smart manufacturing. So it may be applicable as the use case changes: healthcare, energy, transportation, agriculture, manufacturing, whatever it may be. The use cases may change, but ultimate technology will remain the same. It's not a machine connected to internet nowadays. As I said in my introduction, IoT is some machines or some devices connected together or connected to the internet. But nowadays, IoT sensors or IoT devices are intelligent partners in shaping the world. And also C-DAC as a whole, not for this particular case, looking for potential partners who can execute. In my case, the NPK sensors, we have to productize it, we have to make it ready for the farmers. So we are looking for some potential partners. And the opportunity ahead, harness the AI, not just to control the machines, and design IoT, not just performance, but purpose, trust, and fairness, as I said earlier. Build ecosystem that are secure, sustainable, and inclusive. So that's all for in my presentation, and it's time for discussions. Thank you.